In this video, I'll show you how to find the transfer function for this second order sallen key low pass filter with pencil and paper. And the first thing we do is replace the capacitors by the impedances, as you can see in the circuit to the right. And then we write up node equations for node VA and node VB. And to do that, we use Ohm's law. After that, we need a constraint, because we have two equations with three unknowns. And the constraint we need is known as a virtual short, which states that the voltage at the non-inverting input of the op-amp is the same as the voltage at the inverting input. So VB is equal to VC, which is equal to VO divided by K, where K is the gain of the op-amp. We insert the value for VB into the second node equation and get the following. And here we want to isolate VA, so we add VA divided by R2 on both sides of the equation and then multiply with R2. Now we have a value for VA, and now let's insert this value of VA into the first node equation. Since VA is represented 3 times in the first node equation, we can put the value of VA outside of parentheses, and then inside the parentheses put the factors that VA is multiplied with. Now we want Vin on one side of the equation and VO on the other side of the equation. So the thing we do here is just add Vn divided by R on both sides of the equation. And we also simplify a term on the left hand side. Next, we divide with VO on both sides of the equation. Next, we multiply with R1 on both sides of the equation, such that we have Vin divided by VO on the right hand side. And finally, we are going to multiply out this parentheses. And first we get this expression. And here I actually make a mistake. I write 1 over K times R2, but it's supposed to be R1 divided by K R2. But I fixed that error later. And finally, the parentheses is multiplied out, and we still have the remaining terms. Those two terms go out, and we're left with these terms. All these terms divided by K, and the last term is equal to Vn divided by VO. We want the entire left hand side to be one fraction, so we multiply with K in both the numerator and denominator of the last term, S times C2 times R1. And now we get one big fraction. But this is not the transfer function. The transfer function is output divided by input, and we have input divided by output. So all we need to do is invert the expression, and then we get the transfer function. Now this is a transfer function, but it is not in standard form. The standard form has the following form, where there's no term in front of the S squared. So we have to divide with C1, C2, R1, R2 in all of the terms of the transfer function in order to arrive at the standard form. And By doing so, we get the following. And we can simplify this term one last time. And then we have arrived at the transfer function in standard form for Sallen-Kid's second order low pass filter.